All right, today we're opening up a case file on one of the planet's most successful microscopic fugitives. A true survivor that has mastered living where pretty much nothing else can, inside the human stomach. The subject's name? Helicobacter pylori. Let's dive in.
So let's start with a wild thought. Imagine an organism so widespread it's a silent partner to billions of people. This isn't science fiction, this is reality. So who is this mysterious guest, and what exactly is it doing inside so many of us?
Yep, 50%. We're talking about half the entire world's population being colonized by this bacterium. And you know, in some places, that number is closer to 80%. It's often passed down in families, living quietly in the stomach for decades.
You know, for decades, everyone blamed stomach ulcers on stress and spicy food, but that all changed because of two researchers, J. Robin Morin and Barry Marshall. Their discovery of H. pylori wasn't just a minor update, it was a total game changer for medicine, and it landed them a Nobel Prize. They proved the real culprit wasn't our lifestyle, but this tiny bacterium.
Okay, so the big question is, how on earth does this tiny organism survive in one of the harshest environments you can imagine? I mean, the human stomach is basically a pool of acid. The answer? It comes prepared. It's got a whole specialized toolkit that makes it a master of survival.
All right, let's break down its gear. First up, it has its own getaway vehicle. These little whip-like tails that let it swim right through the thick mucus in your stomach. Then, it's got this incredible acid-proof vest, which is a really special enzyme we'll get to in a sec. It has the perfect grip to hang on tight to your stomach cells, and, maybe the most clever part, a perfect disguise to hide from your immune system.
This right here is its absolute #1 survival trick, and it is brilliant. See, our stomachs have this stuff called urea in them. H. pylori pumps out a ton of an enzyme called urease, which grabs that urea and turns it into ammonia. Ammonia is alkaline, so it instantly creates this little neutral bubble around the bacteria, like a personal force field against all that acid. It's just genius.
But wait, it gets even sneakier. This is where it goes from smart to downright deceptive. The outside of H. pylori is covered in molecules that are perfect copies of the ones on our own stomach cells. It's literally wearing a disguise made of, well, us. It's a spy in the enemy's uniform. So our immune system just strolls right by, sees it, and thinks, oh, that's one of ours, and leaves it completely alone.
So it's not just good at defense, it's also got some serious weapons. It pumps out these powerful toxins that directly damage the cells lining your stomach. And as a double whammy, it messes with your stomach's ability to produce its own protective mucus layer, basically weakening the shield that's supposed to protect it from its own acid.
Okay, so we know how it gets in and how it stays alive. But what's the actual damage? What does the crime scene look like after H. pylori has been hanging around for a while? Let's connect the dots.
And the evidence? It's absolutely undeniable. H. pylori is public enemy #1 when it comes to peptic ulcer disease. We're talking a staggering 70% of ulcers in the duodenum, that first part of the small intestine, and about half of all ulcers in the stomach itself. This is that huge discovery that won the Nobel.
And if you've ever known someone with an ulcer, the symptoms can be super specific. A gastric ulcer, the one inside the stomach, usually hurts the most when your stomach's empty. But with a duodenal ulcer, the pain tends to kick in a few hours after you've eaten. It's a classic telltale sign that doctors look for.
But ulcers, believe it or not, aren't even the most serious charge on the list. The constant inflammation it causes makes H. pylori a major risk factor for stomach cancer. It's also the single biggest cause of a rare cancer called gastric malt lymphoma. And get this, in a lot of those cases, if you get rid of the bacteria, the cancer actually goes away. That's how direct the link is.
So, with all these risks on the table, finding out if you have this thing is obviously super important. So, how do we actually catch it? Well, the detective work here is pretty cool.
Basically, the tests fall into two camps. You've got your non-invasive ones, which are easy and are usually the first step, and then there are the invasive tests, which are a bit more involved and require a procedure called an endoscopy to go in and get a direct look.
Now, the urea breath test is probably the cleverest of the bunch. It's so smart because it literally uses the bacteria's own superpower against it. You swallow a little capsule with special urea in it. If H. pylori's home, it gobbles up that urea and spits out a special kind of carbon dioxide. Then you just breathe into a bag, they test your breath, and boom, gotcha.
Now that's not the only tool in the shed. There's also a fecal antigen test, which looks for signs of the bacteria in a stool sample. Or, if they do go in for a biopsy, they can do a super fast test right on that tissue sample, or even just stain it and physically see the little curved bacteria under a microscope.
All right, so the perp has been identified. Now what? Time for the takedown. But this isn't a simple job. This thing is tough, really resilient, so you need to bring in the whole team.
And this is really, really important. You can't just throw one antibiotic at it. It's just not going to work. The bacteria is way too good at building up resistance, and the acid in the stomach makes it tough for the drugs to do their job. A one-on-one fight is a losing battle.
So the answer is a full-on combination attack. The standard approach is called triple therapy. First, you take a drug to lower the stomach acid. Then you hit it with 2 different antibiotics at the same time. And if that's still not enough, doctors bring out the heavy artillery, quadruple therapy, which adds a bismuth compound. And yeah, that's the same active ingredient in Pepto-Bismol.
But you're not done just because you finished the pills. You've got to make sure you actually got them all. So a few weeks after treatment, it's usually back for another urea breath test just to confirm the bad guy is really gone for good. You have to be sure the case is closed.
So we've spent all this time painting a pretty clear picture of H. pylori as the villain, right? I mean, ulcers, cancer, it's bad news. But here's a final twist. Some new research is suggesting that having it around might actually protect us from things like bad acid reflux or even allergies like asthma. So what is it? A clear-cut villain we need to wipe out? Or maybe a complicated old friend we just don't fully understand yet? Something to think about.